Hi everyone. So in this video we'll be covering the topic of functions in O levels. So basically a function is a relation in which every element in the domain has a unique image in the codomain. Now some examples of functions are these. F of x, this is read as f of x equals to 2x plus 1. As you can see over here, it's a linear function. F of x is equals to x square plus 5x plus 6. It's a quadratic function. Similarly, x cube plus 2x square plus 3x plus 4 is a cubic function. And 9x minus 2 over x minus 2, it's a reciprocal function. Reciprocal function where your x value cannot be equal to 2 because this function is discontinuous at a value of x equals to 2, and we'll be covering this in details in the coming slide. Now the thing is that how you determine, like how you write a function. Now function can be written in two forms. These are the two forms. You can write f of x is equals to x plus 3, that's one of the form, or f such that x, which also means that f is a function of x plus 3, there's an arrow over here, x plus 3, and you write the domain after it. X belongs to all real values. Now domain is a set of all values of x, and range is a set of all values of f of x. So if x has an input of x, it has a value of 1, so 1 is the value of this from the domain. When you insert 1 in the function, the output that you get is 4, so 4 is the set of values from the range. Now the function f of x is also called mapping, which means that if you place 1 in place of x, the image you would get is 4. So you can say that 1, the value of x as 1 is mapped onto 4. So f of x is also another term for mapping. Now the first thing that you all should understand is how to verify if a relation is a function. So not every relation is a function, alright? So let's consider this example in which you have been given two examples and you need to identify which one is this a function or is this a function. Both are relations because the first set is related to the another set somehow. So let me call this as my domain and this will be my codomain. This is the domain and this is the codomain. Now in the first example we need to identify, okay, let's revise the definition of a function. In a function, every element in the domain has a unique image in the codomain. So let's look at the first example. Every element in the domain has a unique image in the codomain. Alright? So the first one is yes, it's a function. Yes, it's a function. Why? Since every element in the domain has a unique image in the codomain. Now let's check for part B. In part B, the value of t has an image of 1 as well as 4. So we can see that the input or the element in the domain does not have any unique image. It is having an image of 1 as well as 9. So there isn't any unique image present. The value of u has an image of 16. The element v has an image of 4, and w doesn't have any image. Alright, so definitely it's a relation, but it cannot be called a function, as for the function every element in the domain must have a unique image in the codomain. So you will say no, this is not a function since the element t in the domain has two images. What are the two images? The two images are 1 and 9. And even the element w does not have image in the codomain. So let's revise the definition of a function once more. Every element must have a unique image in the codomain. So over here I had two images from coming out from T. So this is one of the reasons why it's not a function, and W doesn't have any image, so it's also not a function. That's another reason for it to not be a function. Alright, so in this question you have been given a function f of x and g of x, and you are being asked to evaluate each of the following or find the value of each of the following. So in part 1, okay, so the function is, this function f of x can be written as f of x is 3x plus 2. This x is your independent variable and your f of x is your dependent variable, because f of x depends on the function, on the values of x. Now f of 1 plus f of 2 is the question. So f of 1 means simply to plug 1 in the function of f of x, and g of 2 means simply to input 2 as your value in function g of x. So when you place 1 in the function, you get, that's your function f. In place of x you have to insert the value of x as 1. And for function g was 5x minus 4. So in place of x you will insert 2 and evaluate the two answers and then add them. And when you solve them you get 11. So that's the answer for f of 1 plus g of 2. Now for the second part, you have to find the value of x for which f of x is equals to g of x. Alright, so we need to come up with that value of x where my function f of x is equal to g of x. So I know that f of x is 3x plus 2 and g of x is 5x minus 4. You will equate the two functions and solve for x, and you will get the value of x as 3. So for x equals to 3, f of x will be equal to your function g of x. Now in part 3, you have to find the value of x for which f of x is 17. F of x is equal to 17, that is been given to you. The image has been provided to you. You need to figure out that what value of x corresponds to the image of 17. So the function f of x is 3x plus 2, and you will solve this. The value comes out of x comes out to be 5. So for x equals to 5, the image would be 17. Okay, so sometimes you might be asked to express values of functions in algebraic expression. For example, if you have been given a function f of x, small f of x and capital F of x, these are two different functions, and instead of values being assigned, you are being given a variable. So you need to come up with an algebraic expression after plugging in these values in the same function. So in first part, for this question you are being asked to calculate f of a, which means you have to use function f of x. F of x is 7x minus 4, and in place of x you will insert a, and the output would be 7a minus 4. That is your expression when you insert a into the small function f. Part 2 says capital F of a plus 2. Now capital F of x function is 6x plus 5. In place of x I have to insert a plus 2. So in place of x you just plug in a plus 2 and simplify this. Okay, and you get 6a plus 17. That is your image of the function when you place a plus 2 in this equation, in this function. Now for the third part, which says small f of 3a plus capital F of 2a plus 1. Now in the function small f of x function, which was 7x minus 4, in place of x you will place 3a. That's your small f function. As for your capital F of x function, you had 6x plus 5. In place of x you will, now the input would be 2a plus 1, and then you resolve it. Simplify this. And this is the final answer that you get. So now let's look at problems involving functions with higher order expression, which means that no longer a linear function, any other function. Okay, so this time we have a quadratic function, and like the previous question, in this question also you will be expressing each of the following in terms of x now. So f of 2x simply means in function f, in place of x, you have to insert 2x. Okay, so when you simplify this you get 4x square plus 6x plus 2. Similarly for the second part, what you need to do is realize that you knew that f of x is x square plus 3x plus 2, right? So f of 2x plus 1 now would mean, in place of x in the function, plug in 2x plus 1. And be careful while expanding this. This is in the form of a plus b the whole thing square, which can be expanded as a square plus 2ab plus b square, and this would be 4x square plus 4x plus 1 plus 6x plus 3 plus 2, and after you have simplified this you get 4x square plus 10x plus 6. Make sense? Now for part 3, it's f of x square plus 1. So the input in place of x would now be x square plus 1. So the function remains same, which was x square plus 3 times x plus 2, and in place of x all you need to do is plug in x square plus 1. Similarly, you have to be careful at this stage where you have x square plus 1 the whole thing square, and it needs to be expanded using the expansion identity of a square plus 2ab plus b square. So when you expand this you get x4 plus 2x square plus 1. You multiply this, you get 3x square plus 3 plus 2, and then all you need to do is simplify this. So you can come up, you could be asked questions for higher order expressions as well. Okay, you might come across questions in which functions are given to you, but there are some unknowns, and the information regarding few values are given. For example, when you insert 2 in function g, the output is 6. When you insert functions input the value of x as 7, the output is 16. Okay, and you have to find the unknown values. So since two informations are given to you, like for example when x is 2 the output is 6, and when x is 7 the output is 16, you will have to solve such questions simultaneously. So let's make the equation first. Now we know that the function g of x is hx plus d, but I don't know the values of h and d that are needed to be found out. So I know this, that when I insert 2 as my input in this function, the expression would become h times 2 plus d, and all of this would be equal to what? 6. So the first equation that comes out is 2h plus d is equal to 6. The other piece of information given to you is, like when you insert 7 in the function, you get h times 7 plus d, and the result would be equal to 16. So this another equation comes out to be 7h plus d equals to 16. Okay, now either you can do elimination or substitution, up to you, but you have to solve these two equations simultaneously. Alright, so when you solve these two equations simultaneously, you will get the values. So let's say using equation 1, I'm going for substitution. Okay, using equation 1, make d the subject. So d would be, from equation d would be 6 minus 2h. Put d is equals to 6 minus 2h in equation 2. So the 7h plus d equals to 16 was your second equation. In place of d you will place 6 minus 2h, so that your entire equation is in one variable, which is h. So 7h minus 2h, 5h plus 6 equals to 16, and h value comes out to be 2. So when h is 2, d was equals to 6 minus 2h. So d would be equal to 6 minus 2 times 2, which is 6 minus 4 and 2. So d is 2 and h is 2. Now once you have found the values of d and h, what they are asking you is to evaluate g of 5 and g of minus 3. Now your function now becomes, once you know the values of d and h, your function g of x now becomes 2x plus 2. Okay, 2x plus 2. Now g of 5 was to be found out. So 2 times 5 plus 2, 12. And g of minus 3 was to be found out. So 2 times minus 3 plus 2, minus 4. Alright, so the next cool thing that we are going to discuss is the idea of inverse function. But before that, let's consider the simple function f of x equals to x plus 2. Now these are the elements in my domain, and when I insert these values in my function, which is f of x is x plus 2, so when I insert 1 in my function, I get 1 plus 2, 3. So these are the values of the codomain. Similarly, when I insert 2, I get 4. When I insert 3 in my function, I get 5. And when I insert 4, I get 6. So all of these values are the elements of the codomain, which means that these are the output. Now inverse function is a function that has a opposite or the reverse effect of the function. So I need to come up with that function in which when I insert 3, I get back 1. Getting it? So when you insert 3 in the function, you get 1 back. When you insert 4 in the function, you get 2 back. So I need to come up with that function. Okay, now inverse functions are, the notation for the inverse function is this: f inverse of x. So now here is a pointer. F inverse of x is not equal to 1 upon f of x. Okay, f inverse of x, since many students get confused themselves that if there is a power of minus 1, so this would mean that it's equal to 1 over f of x, which is not the case. This is a specific way of writing f inverse of x. Now f inverse of x must be a function which has a reverse effect of the main function. So I need to come up with a function in which when I insert 3, I must get 1 back. If I insert 4, I must get the value of 2 back. And when I insert 5, I should get 3. And when I insert 6, I must get 4 back. Okay, so let me clear this out with a simple example. These were the values of x. This is my function. The output that I'll be getting is f of x. Now inverse function is a function in which when these values, the values of f of x when are being inserted, you will get back the value of x. Okay, so you need to come up with the expression or the function itself for the inverse function. One more thing to keep in mind is that inverse function must also be a function itself. Remember the discussion we had for the definition of function, that every unique element in the domain must have a unique output. So inverse function must also be a function. You need to note that not all functions have inverses. For example, the function f of x equals to x square will not, although this is a function, but it will not have an inverse. Okay, the inverse is not a function, since every positive number x square has 2 square roots. Either it can be x and minus x. So f inverse cannot be defined for these values. Now in this basic example, we will learn how to find the inverse of a function. A function f is defined f such that x is x plus 2. Find the inverse of f inverse. Find the inverse function basically, which is denoted as f inverse. Now I'll tell you the steps. So f of x, which I can also write in this form, f of x is equals to x plus 2. Okay, the first step that you will do is replace f of x with y, and then make x the subject. Make x the subject. So x would be equal to y minus 2. Okay, now for inverse, in order to write inverse function, you will write f inverse of x in place of x, and your y would become x. This is how you will write inverse function. Remember, what happens in an inverse function is that if I have a value of 1 and let's say the image is 3, for an inverse function the output y would become the input, and I must get back the input of the main function, which was 1. So f inverse of x is, this is how you are going to write f inverse of x. Okay, so I'm repeating that f of x is equal to x plus 2. Okay, replace f of x with your y and make x the subject. Once you have done this, replace x and y. Okay, so x will now become your f inverse of x and your y would become your x. Now let's look at a more comprehensive example on function and inverse functions. So in this example, you have been given a function, okay, but it's a reciprocal function, okay, where x is not equal to 2. Now why is x not equal to 2? Because your function becomes discontinuous at x equals to 2. Now see what will happen when you will insert x as 2. When you insert x as 2, the numerator is fine, but in the denominator you will get 0, and it will make your function undefined. It will make your fraction undefined. So this means that the function can have any value other than 2, because at 2 the function will not be continuous. you need to find the inverse function f inverse of x and then state the value of x for which f inverse is not defined. Okay, so let's go step by step. We know that the function f of x is 9x minus 2 over x minus 2. The first thing that you must do is replace f of x with y and then make x the subject. So you need to do some algebra over here. Have all the x terms on one side. So you get yx minus 9x equals to 2y minus 2. Now you need to make x the subject, so you need to have x common out. Okay, and when you make x the subject, you get 2y minus 2 over y minus 9. But the next step was to replace x and y, because in an inverse function they are replaced. So your x would become y and your y would become x. This is your inverse function. The way you are going to write an inverse function is this: f inverse of x in place of y, 2x minus 2 over x minus 9. Now this is your inverse function. The next thing that you are being asked is to state the value of x for which f inverse of x is not defined. So likewise, the function itself, the way we figure out that you can't have 2 in the denominator, because when you insert 2 in the denominator, the function would be undefined because you will have denominator as 0. So by looking at the inverse function, look at the denominator. The denominator can have any value of x, any real value of x, except 9, because when you insert 9 over here, the denominator would become 0. Therefore you can say that x cannot have a value of 9. So at x equals to 9, the function would be undefined. So at x equals to 9, the f inverse of x function will not be defined. Alright, now a simple task. You are being asked to calculate f inverse of 1 over 4. Since you have f inverse of x expression, which is 2x minus 2 over x minus 9, all you need to do is, in this inverse function, plug 1 upon 4 in place of x. And after evaluating this, you must get 6 over 35. Now let's look at some problems that are a little bit complicated, in which you might be asked to solve simultaneously. The function f is defined as f such that f follows a function, f is a function of x, which is ax plus b. Given that f of 2 is 10 and f inverse of 3, meaning when you insert 3 in inverse function you get 1, you need to find the values of a and of b. Now we know that in the function f of x, since f of x is a function of x, you will have x as the input values and the output would be some values, right? The output would be ax plus b. So if x is 1, then it would be a plus b. If x is 2, then it would be 2a plus b. Now the question says that when the input is 2, the output is 10. So when x has a value of 2, the output must be 10. So f of 2 is equals to 10 simply means that in a function, okay, so let me write the function again. F of x can be written as ax plus b. Now when I place f of 2, so I get a times 2 plus b, and the output must be equal to 10. So if you simplify this, you get 2a plus b is equals to 10. That's your first equation. Now how do you plan on utilizing the second part? The second part says f inverse of 3 equals to 1. But you know what, we don't have the inverse function up till now, okay, but we don't need inverse function as well. all we need to know is the idea of the inverse function, what a inverse function is. So inverse function is basically works as a reverse of the function. So I can say that if this would have been an inverse function, and as per this information, when I was plugging in 3, the output of the inverse function was 1. And remember this, that if output of the inverse function is 1, which means it becomes the input of the main function, and the output of the original function would be 3. So I'll write it in a simpler way. The thing is that if f inverse of 3 is equals to 1, then you can say that f of 1 is equals to 3. So I can use the same equation given to me for f of 1 equals to 3. So a times 1 plus b equals to 3. A plus b is equals to 3. That's my second equation, and let me call this my first equation. You can do elimination or substitution, up to you, and solve simultaneously. So after solving simultaneously, you must get values of a and b, and if you work it out correctly, you must get a as 7 and b as -4. Thank you for watching this video. I hope it was helpful for you all. Please give it a like and share.